The best way to get better at programming is to practice. And in this example, we're going to create a basic templated function. As always, this file is available for download using the link in the description below. We'll pause for a couple seconds so you can download it. All right, so I'm going to first come in here and create a basic template. So I'm going to say template, type name T. T is going to be our generic whatever is going to come into this place. So it's going to be replaced by whatever data type we're going to use. We're going to specify something that's going to return the max type value. So I'm going to say my return type is going to be T, max value T, comma T. And this is our function prototype. Then our function definition, we're going to have T, max value T. We're going to call this value 1, comma T, value 2. Now you might notice that, hey, it's not liking this. And this is partially because we need to define the fact that we're using a template here. So you're going to say template, type name T. And now notice that everything works. So this is a little bit different than defining a regular function after defining the prototype. Now I'm going to come in here, I'm going to say if value 1 is greater than value 2, return value 1, else return value 2. Okay, now a couple of quick things. This is going to work for anything that C and C++ knows about the greater than symbol in correlation with that data type. So an int, a double, a string, etc. However, if we had defined our own data type, we have to make sure we define the operator greater than for that data type if we want to use it with max value. The nice thing with the template is it changes however we want to use it. So for example, I'm going to create one more function. It's going to be void display max T, comma T. Notice that if I try to do this, however, it says, wait a second, I don't know what T is. That's because even though I define template type name T up here, it doesn't necessarily bring it down. So I need to put this for every function. And then I'm going to come over here, have my template type name T, void, and then my function name, which is display max. Then I can have T, value 1, comma T, value 2, cout between value 1 and value 2, blank, values max value, value 1, value 2 is bigger. And L. Now I can come in here and say display max, and I'll say 4, comma 8. And this is going to work as integers. That T can be converted with integers. I can say display max, and I can give it 4.5, comma 5.6. It's two doubles. That's going to work. Display max, A, comma lowercase a. Okay, so we got a couple different values here. And if I go and run this real quick, it says between 4 and 8, 8 is bigger. Between 4.5 and 5.6, 5.6 is bigger. So we see all these different values in here. Notice that it used characters, integers, doubles, etc. That was all good. Now, here's the key thing. Notice that I specify that in both display max and max value, T is used consistently for all three data types. That means it has to be the exact same data type. I can't mix these. So for example, if I say A and then I try to compare it with the big one, my string, and I try to say, you know what, 4.5 and 5, Notice I get errors on both of these. It gives me a little red underlined squiggly because it says, ooh, these are two different data types. And that's not what I'm expecting. I'm expecting the exact same type. So I don't have an example where I can use a double and an int, or a character and a string, or an integer and a floating point, or anything that's mixed. They must be the same data type. If I want to use multiple data types, I could. I just have to write my template slightly different to allow to have multiple type names and give it a different value. So instead of T, I might have T1 and T2. Hopefully this helped explain templates and made it a little bit easier for you to understand. If so, give the video a like and consider checking out the rest of the series so you can get better at programming C and C++.